In 5.2, we will talk about the negative exponents in the scientific notation. Let's check the first objective. So, how can we simplify the expressions with negative exponents? So, if here we have the negative exponent, right? Negative n. So, we should write it into this form first. We should write 1 over. 1 over what? It should be 1 over a to the positive n. A to the positive n. So, for example, if we have x to the negative 3. So first we know it's a negative exponent, so we should write 1. 1 over, then we still copy the x, but this time, because we are already in the denominator part, so we just write the positive exponent, x to the third. So make sure you can memorize this form. Okay, let's check some examples together. So first example, how to evaluate this one. So we realize it's a negative sign in the exponent, so which means we should put 1 over something. Then we write the denominator part to be 3 to the second. Okay? Because when you simplify the expression, we cannot see any negative exponents. Okay, we could not. If you have the negative exponents in your expression, you need to simplify until you only have the positive exponents. So let's check another one. How can we simplify this one? So first, this is just a product. The 2 is not included in our base. So 2, we can just keep the 2 times x to the negative 3. So for this part, we know x is the base for this term. So we write 1 over x to the third. So after that, you could write like this way. You could write it like this way. 2 over x to the third. Okay, let's check another one. 2 to the negative 1 plus 4 to the negative 1. So again, here we have the negative sign. Then that will be 1 over 2 to the positive 1. Plus 1 over 4 to the positive 1. So after that, we will have this, and we know it's 3 over 4. Let's check another example. This time, we have a negative sign in our exponent, right? Which means we should write our answer into 1 over something. But what is the base we have? Remember, the whole part in your parentheses is just the base. So negative 2 is our base. Now, because we already in the denominator part, so we will just write negative 2 to the fourth. So for this answer, we will have 1 over 16. Okay, 1 over 16. So again, we know if a is not equal to 0. Again, we write the rule. A is not equal to 0, then we can write a to the negative n to be 1 over a to the n. But if we have 1 over a to the negative n, so remember, we could not have negative exponent in our expression. When we have negative, we will try to make it to be the positive. So if it's negative in the denominator, you could change it into this form. There will be a to the n. Okay, it will be a to the n. This is very easy to understand. It's just like, 1 over, and for the a to the negative n, you will also have 1 over a to the n. After that, you realize you will just get this. You will just get this. Okay? So if possible, try to memorize this rule. Try to memorize this rule. Now we're going to talk about the second objective here. We will talk about how to simplify the exponential expressions. So don't forget, we can use several rules to help us simplify. So remember, we have the product rule. Just a quick review, product rule. So we do the multiplication, but we have the same base. Now we keep the common base, but find the sum. Okay, and we could have the power rule, right? So inside we have a exponent. Outside we have another exponent. So we keep this one. This is actually the base of the inside part, right? Then find the product of two exponents. This is called the power rule. We also have the power rule, a power of a product. So that means inside the parenthesis, we have a product. Then after we put the exponents to the term, we still have the form of the product. Of course, we will also have the power of quotient rule. So if inside it's a quotient, then after we put the exponent to it, it's still a quotient, right? So we also have the quotient rule. This two called the power of product, power of quotient. And another rule is called the quotient rule. So we do the division, but this time we have the same base. So we still keep the same base and make sure you find the product m minus n, the top one minus the bottom one. The top exponent minus the bottom exponent. Okay, another rule is called the zero exponent. So any number to the power of 0 is equal to 1. But make sure a is not equal to 0. Of course, for this rule, we also should a non-zero number. Of course, the last rule we just learned today is the negative exponent rule, right? If we have a negative sign, then we will write 1 over a to the n. 1 over a to the n. This one still need to have a non-negative number. Of course, for this one, we also have this rule. If we have a negative in our denominator, we can write it into this way. Okay, a is still not equal to 0. So we're gonna use all of these rules to help us simplify the expression. Let's check some examples. So I think that's all of the rule we could use for the operation about the exponents. Okay, so let's check some examples. For example, the first one. So first of all, we could use this one. The negative sign for this then we can treat it as we use the negative exponent rule. We know we could treat it like 1 over the whole part to the third. If you want, you can first write it into this way. So after that, you maybe realize it's just 1 over, let's see, check the top, we could use the power of quotient rule, right? Then we should use power of quotient rule to put it into 3 a squared to the third. Then the bottom part is still the quotient. After that, we think 1 over it is just find the reciprocal of this whole part. Then we could change the order of the denominator and the numerator. So we could get 3. Now, for the bottom part, we only need to use the power of product rule. Then it will be 3 to the third, then a to the third, right? So after that, we could write our answer like 27. 3 to the third will get 27. And the last one, a squared then to the third, that's the power rule. A, keep the a, then 2 times 3. So after that, we get it. Maybe when you do your problem, we do not use the same rule. Maybe the order does not the same, but we can always get the same correct answer. The rule you use may be different to me, but it's okay. Let's check another one. This time we have 5y to the negative. Okay. This time we're gonna use the power of product rule first. So we're gonna treat it like 5 to the negative 2. Okay. Then times y third to the negative 2. Okay, after that we will have 1 over 5 to the 2 times the first we're gonna use the power rule to keep the y, then find the product of y times negative 2. We will get a negative 6. So we will have 1 over 25 times 1 over y to the 6. So after that, you can combine your answer like this. So the order of the rule you are using does not matter, okay? You can, something like, I will do the first the question into another way. Let me see. First, I will use the negative exponent rule. Then we will write the whole part into 1 over, now 2. I will use positive 2, right? I use the negative exponent rule to write the negative exponent to be a positive 1, to be 1 over it. After that, you treat the whole bottom part as the power of the product. Then you will see you have 5 to the third and the y to the y third to the 2. Then you will have this term as 25. In this term, you use the power rule. You will have 6. So you will still get the same answer. So the rule you use, you can put them in any order you want, but make sure you use it correctly. Okay, so let's check one more. So this time we have to do the quotient rule first. Oh, not quotient. Yeah, we will say we just do the power of product. So we will treat this whole part is the product. Then we will write it like 2 to the negative 3 times x to the negative 3, right? Y to the negative 3. So the power of the product, still the product. So the second part, the bottom part, we will do the same thing. And 6, right? After that, that's the power rule. And the power rule, and yeah, I just combine 2 rules. Yeah, I will show you it. So first, I just use the power of the product. So it's the product, x squared into the second. Then after that, we could use the power rule to get. Now we're going to use quotient rule. 2 to the negative 3 divided by the 1. So we will still get 2 to the negative 3. In the second term, we will use the quotient rule because we have the same base. X negative 3 divided by x 4. So we will get x negative 3 top quotient minus the bottom quotient. And the last term, y negative 3 minus 6. The top quotient minus the bottom quotient. After that, we will get 1 over, okay, let me show you. 1 over 2 to the third, and x negative 7, so 1 over x 7. Y is negative 9, so 1 over y to the 9. So after that, we combine our answer into this form. Okay, we combine this answer into this form. Anyway, you could not have any negative quotient in your expression. You should simplify the negative exponent, change it to be the positive one. So that's all for all the operations for the exponent expressions. Next topic is about the change the number into scientific notation. Okay, so the scientific notation actually have this form. It's a times 10 to the r's power. This is called the scientific notation. And here a is a number greater than or equal to 1 but less than 10. This is called the scientific notation. Okay? And for example,